All right, so overall, people did a pretty good job on the rewind. The thing that I want to reiterate and make sure that you guys know, because I really don't want to have to take points off on tests and quizzes, but when it's an axis of symmetry, how do you have to write your answer? It has to be x equals. And why is that? Why can't it just be 3.5? Because that would just be a what? That would be like a dot. An axis of symmetry is what, though? It's a whole what? It's a whole line, which is why you have to have the x equals, because it's the entire line that goes down through 3.5. Why was that one 3.5? Why was there a decimal there?
Because it was 2 plus 5.
Yeah, it was in between two whole numbers, but they were not separated by an even number. So it was 2 between 2 and 5. So to do that, you can do 2 plus 5 divided by 2, which gives you 3.5. Or you can just kind of count it out in your head. Okay? All right, so when you're finding the vertex of each parabola, this is kind of the culminating thing that we did yesterday, on Tuesday. So what do you do to find the vertex? What do you have to find first? The x, which is our axis of symmetry, and we do that using what formula? Yeah, so the opposite of b over 2a. And the reason we say the opposite is because sometimes, like, putting a negative throws people off. So the opposite of b would be what? 6. And then what's 2a? Times 3. Okay, so then it became 6 over 6, which equals 1. So our x equals 1. And then what do you do to finish finding the vertex? Plug it in to where? Good, into our original equation, not into the opposite of b over 2a. So then it becomes y equals 3, 1 squared, minus 6 times 1, minus 2. Why do I put it in parentheses? Because it's multiplication. Does it really make a difference as much because the 1 is positive here? No. But if it's negative, does it make a difference with the exponents? Yes. So when you do it, just get in the habit of putting it in parentheses, especially if you are somebody who just puts it straight into your calculator, which is fine. I support doing that. Just make sure you do it in parentheses. So then 1 squared ends up being 1, so 3 times 1, minus 6 times 1, minus 2. What is 6 times 1? What is 3 times 1? So 3 minus 6 minus 2, which ends up giving you negative 5. So your answer ends up as 1, negative 5. Okay? A lot of people did all that work too for number 7. You don't have to. For number 7, you're just looking for the axis of symmetry, so that's just the x value. So I wouldn't mark you wrong if you did all that. Just save time. Okay? You don't have to. Read the directions carefully. All right, so today we're going to talk about kind of the final step here, which is how to graph these quadratics. We've learned about all the parts of a quadratic function. There are a lot of them, right? We talked about direction. We talked about, what else did we talk about? Axis of symmetry, vertex, domain, range. We talked about a lot of different topics. But today we're going to talk about how to graph it onto a coordinate plane, which ends up kind of being the most important thing. So every quadratic function can be written in this form. Does it always have a b and a c? No, but it has to have a a. It has to have that ax squared. There has to be an ax squared. If there's no number in front of it, if it's just x squared, what do you assume your coefficient is? Good, you assume it's 1. Okay, so when we're doing these, just keep in mind that that's always our standard form. And if we've talked about this before. You guys did a little bit of these graphing problems before, but to graph them before, what did you have to find? What did you have to do when we graphed them a couple days ago? I think it was on Monday. You had to find you had to pick a bunch of x's, right? And then what? You found a bunch of x's and then did what with those? Plugged them in and then found what? All the y's that went with it. So Brennan showed us how to do that on our calculator, right? We did it with the tables, and then that's how you graphed it. So we found a whole bunch of x's, and then we plugged them all in, and you ended up with a function table that looked like this: x, y, -2, -1, 0, 1, 2. And then you plotted it onto the coordinate plane once you plugged it in and found out all your y's here. Okay? A couple issues with that. One, it can take a while. 2, sometimes that doesn't give you the vertex. So this happened, I forget which one we were graphing, but this happened at one point where when you ended up doing that, it ended up looking kind of like this. Like it was just this part of it. And if you just see that part of it, you might think that this is a what? A line. It might look more like a linear function than a quadratic. So what we're going to talk about today is how to graph these without using those points, without having to find the table, and how we can use that to make sure that we have the exact right graph of our quadratic function, where we're getting the whole parabola. So there are a couple steps here, but they're similar to what we did yesterday. So the first thing you want to do is find the axis of symmetry. And how do we do that? Equation is... Okay, in this case, what would negative b be? 4. And what's 2a? 2 times 1. Okay, so it ends up as 4 over 2, which is what? 2. So x equals what? X equals 2. So our axis of symmetry is 2, which means if I'm on a coordinate plane, 1, 2, here's my axis of symmetry. Which means wherever the parabola is, that's going to be through the middle of it. Okay, so the first thing you do is find your axis of symmetry. So there's our axis of symmetry. What else do you think we need to do then? Plug it in to find the y so that we can find the vertex. So then the next thing you want to do is plug it in to find the vertex. So we got that x equals 2. So when I plug that in, what does it look like? Good. Okay, what's 2 squared? What's 4 times 2?
8.
Minus 5. So what's 4 minus 8? Negative 4 minus 5? Negative 4 minus 5. Negative 9. Good. So so y equals negative 9. So then what's my vertex? 2, negative 9. So that's my vertex. Okay, which means that's the point where my graph either goes up or it goes down. How can you tell which way it's going to go? Okay, is the A negative or positive? So that means my graph is going to go up. So if we go back to this, here's my axis of symmetry. I go down to negative 9. Here's my vertex. And I know it's going to open which way? So it's going to go up like this. But do I know how wide it needs to be? So that's the last thing I need to figure out. How wide does it need to be? And to figure that out, we find the y-intercept because that'll let me know where it crosses the y-axis. So think way back to linear functions. What is the y-intercept? What does that mean? Where it intersects the y-axis. And how do we find that? What do we plug in to figure out the y-intercept? 0 for what letter? For x. How come? You're figuring out the y-intercept, so you plug in 0 for x. Because if you plugged in 0 for y, you'd be figuring out x, because your 0 would go away. Okay, so then the last thing you do is figure out the y-intercept. So I'm going to plug in 0 for x. This should be pretty simple because it's 0 squared minus 4 times 0 minus 5. What's 0 squared? 0. What's 4 times 0? 0. So my answer is just negative 5. So that's my y-intercept. So I go back to my graph. Should I skip it? There we go. So I go back to my graph and I plot negative 5 on the y-axis. And that's where my parabola is going to go. But parabolas have 2 sides, right? So I can't just use this one. But I don't know how to figure out another point. What do you think I could do, Brendan? Yeah, exactly. Because the axis of symmetry tells you that it's going to be symmetrical, right? Which means that if I go over 1, 2 to get to the axis of symmetry here, how far do I go over to get to the other one? 2 over. So it ends up here at 4. And then now that I have that, that's enough. Now I have my parabola. Okay, so instead of finding 5 points, we're finding how many points? 3. Only 3. And that's fine. If you're looking at this and you would rather do the table on your calculator, that's fine if I don't tell you you have to do it this way. But you have to know this, so at some point you're going to have to do them this way. So for the work today, this is how you have to do it. You cannot use the table on your calculator to figure out 5 points. You have to figure out the vertex, the axis, and the y-intercept. Okay. All right, so that's all the information that we found, and that's how we plotted it. So the vertex was at 2, -9, and again, that was right here. And then the y-intercept was at -5, so that was right here. Since this is our axis, we went over 2 more to get here, and then here's your parabola. All right, so again, first step, find the x. What formula do we use? Negative b over 2a. Next step, plug it in to find the vertex. Yeah, so now we have the vertex. Last step, find the y-intercept. Once you have the y-intercept, what do you have to do? Just count it. Yeah, count how far over you go and go that far over again, which means you have to draw your axis of symmetry. It also means you have to know, since this is positive, it's going to open up. Okay? So the biggest thing that I see people do is treating the y-intercept like the axis of symmetry instead of the axis of symmetry. So draw that axis. First thing first, draw that axis. Okay? All right, so let's try one more, but take a look at this equation. What's wrong with it? It's not an ABC form, right? It's not in the standard form, so what do I have to do with this 6x? Get rid of it, which how do I do that? Subtract it. And then from over here, are those like terms, any of them? No, so it just ends up being, how do I write my equation then? X squared. No. Minus 6x plus 9. How come I do it like that? I need it in ABC form, right? A always goes with the x squared, B always goes with the x, and C always goes by itself. So you have to have it in this format. Okay, so now axis of symmetry, what do I do? Which is opposite b 2a. So what would that be in this case? 6 over 2 times 1. What's 2 times 1? And what's 6 divided by 2? So then my axis of symmetry is x equals 3. So I'm going to draw that right now. Before I do anything else, I'm going to draw that. Okay, so there's my axis of symmetry. So that's the middle of my parabola. How do I go about finding my vertex now? Plug it in. So y equals 3 squared minus 6 times 3 plus 9. What's 3 squared? What's 6 times 3? 18. What's 9 minus 18? Negative 9 plus 9? 0. So y equals, so what's my vertex? No. 3, 0. Good. Okay, so 3, 0. So my vertex ends up being right here. So I now plot that vertex. All right, and then the last thing is find the y-intercept. How do I do that?
Well, you know
Plug in 0 to x. So 0 squared minus 6 times 0 plus 9. What's 0 squared? 6 times 0. So my y-intercept is, so then I put that point right here, which, like Brendan said, I already know my vertex, or not my vertex, my parabola is opening up, so it makes sense that the y-intercept will be up there. Now, how do I find that third point? I see it's over 3, 1, 2, 3, so I go 1, 2, 3. And there it is, and here's my parabola. It's always a V if you zoom in enough. So mine always look more like V's just because I just draw it straight up from the vertex. If you draw it like this, like that's not, I'm not going to mark it wrong, right? Like however you go, as long as you're these are the 3 points I'm looking for. If you draw, even if you did like weird curly cues, I mean, that's clearly wrong, but I don't really care as long as you have your 3 points, okay? Actually, don't draw curly cues. Okay. But really, like, I'm not going to nitpick like, well, this isn't exactly 1/10 of an inch from where it should be. I don't care about that. I just want to know, do you have your 3 points, and did you draw your axis? If you don't draw your axis, people will get it wrong, I guarantee it. Okay, so take the 2 seconds it took me to draw that dotted line and do it. Okay, try this one. Try it at your boards. If you want to practice plotting it on the actual slides, you can, but do this one at your boards.